All right, while we're waiting for the system to come up, my name is Vince Weston. I'm a technical evangelist. I work for Dell, and I'm here not as anything official from Dell, just here to talk about robotics. I have been working with FLL and FTC teams for a decade, so I have a little bit of time here that I've been involved to offer help from, some knowledge. There's some space here in the middle. Some folks want to sit. There's some more space along the back. Go want to scoot over a little bit more. We're making a video of this, so it'll be on the web. So if you have other team members who can't be here, they can look at it. We've got PowerPoint from this. How's it? Is it up? Hit PC if it's up. On the top, up far end. So our goal is today to go through how to build a robot using the Rev Robotics hubs. So we'll talk through the pieces on that. This will talk about the hardware, how to put all the hardware together, how to wire it up, how to set up the XML to control that, to map it to the software. We did a separate software class that just finished that talks about how to go from there to programming the whole thing. That video is also going to be online, and all the PowerPoint for that, the code for that, including the autonomous and using the IMU to do guided driving and all that, is in the default code. So feel free to download all of that when we get done. All right, hold on, I gotta. Yes, no, yes, no. Camera, projector's on. Trying to wake up the room here. Hold on a second. No control. Projector muted. Let's unmute the projector. There we go. All right. So again, my name is Vince Weston, and there's a QR code here. It'll be on the last slide for today. It's also posted on the walls outside the classroom. That goes to a blog page that has all of the PowerPoints and the video. It'll have the videos after today, and it has all the other pieces. Again, so it's got the class here. It's got the software class. It's got the template for something new this year. How many of you have read Game Manual Part 1? Really? You all are here for kickoff and you haven't bothered to read Game Manual Part 1? All right. Let me just suggest, first thing you should do today when you get done, is you're going to read Game Manual Part 2, I'm sure at 12 when it comes out. Go read Game Manual Part 1. It tells you things like how big your robot can be and how to control it. So for those of you who have read Game Manual Part 1, what's the change for Alliance colors on your robot this year?
You have to put them over here. We're not providing flags.
Right. You must put a blue 2.5-inch circle if you are blue, and a red 2.5-inch square if you are red on the side of your robot. Right? The folks hosting your matches will not provide circles or squares. You will bring them on your robot or you will not compete. Right? So to make it easy, this is a PowerPoint file, right? It's got the numbers in the 1/2-inch width, 2.5-inch height, exactly what you're supposed to have to be legal. Just take the PowerPoint that's available on that website, right? Edit your team number in, put whatever comments you want on the bottom, print it, tape it up, two-sided, and you're done, and you have something legal. I am not saying this is how your robot should look and what you necessarily want for competition, but this will let you compete, right? If you don't bring something like this, you cannot compete in any of your matches. Right? You need a team number on both sides as always, but now you also need to be able to flip alliance markers, and it may be easiest just to build that right into your team number. Right? Because you have to have it similar team number, both sides are ready to go. All right, so let's get into the actual discussion. Is this on? There we go. On works better than off. No, where are you going? Wrong way. All right, very nice to stop the presentation. Oops. Start from the beginning. Okay. Let's try this again. So for the overview, we are going to talk about the general robot hardware design, a few concepts outside of what we're doing with Rev just to be thinking about. Then we're going to talk in depth about the Rev expansion hubs. How do you wire them together? How do you configure the XML, which is not always obvious? How do you connect motors and things like that? and then some useful parts and such. And I've got a demo robot here if you want to see it, including an autonomous that uses the IMU so that after it turns, it auto-correct drives in the right direction. Right? And again, that's code you all are going to get. I need a water bottle. As far as you all know, this is full of water. So what's the first thing you should do? Right? Everybody on your team should read the manual. Manual part 1 and part 2. How many of you can read the manual and get everything that's in it? Right? You all are going to miss things. If you have one person read the manual, you're going to have one person's interpretation of what they read. Odds are they will have at least one thing wrong. I've read the game manuals multiple years, multiple times, and been 2 months into the season before I found out that one of the concepts I had firmly ingrained in my head was dead wrong. Right? And you want your team members to start talking to you about that so you don't get your first match and say, well, wait a minute, we thought it was like this. And then, no, read the manual. Right? When Lori has to tell you you've done it wrong and you're now violating rules and you can't compete, not the way you want to start your competition day. So, read through the rules, part 1 and part 2, right? Part 1, all the rules of how you can do things. Part 2 is all the season-specific stuff, right? So the part 1, other than the change of alliance colors, there shouldn't be any big surprises in there for you. Read it anyway, because, again, there are changes like that. Part 2 is going to be all new, and we'll get that in a couple hours. As you get near your matches, read the manuals again. Right? It doesn't hurt to read it again. Before you start the first round of matches, before you start we're going to do super regional stuff. You're going to do your league tournaments, right? League championships. So the league championship. Once you've done league championship, odds are you know most of it, but you're still going to check the forum for updates, right? Because they can change rules. How many of you remember Velocity Vortex when we're throwing things up into a big ring in the middle, right? And we had several teams who started developing, I'm going to go up with a couple of motors and wheels and I'm going to spin the vortex in the middle. And the rule that came out about 2 weeks after the game was launched, because people started putting videos of that up on YouTube, was the rule that said, hey, you cannot reach up and spin the vortex. Right? More than one point of contact was a major penalty. Can't do it. So if you don't read the forum, you wouldn't know. You'd have a whole robot designed around something that was not allowed weeks before. Right? Save yourself the time. Don't build things that are illegal. Read the forum. Right? If your robot is the wrong size, the wrong weight, if you have too many motors, if you have too many servos, if you have sharp edges, if you don't have your team number or your alliance marker, right? If you're throwing things harder than the game allows, right? That's always one of those. If it goes over this height or this distance, and they've checked that, your robot is not allowed to compete. So have the right stuff. You don't want to show up at competition and not be allowed to compete. We have robots that show up sometimes, and it's an 18-inch cube, right? We had a robot show up that was 20 inches in one dimension and couldn't shrink without cutting things off. That's disappointing. The team then can't use some of their key features. Well, okay, but that rule isn't new, right? They said, well, I put the tape measure on it. It's like, okay, so it doesn't cost much to go to Home Depot, spend $10, get some plywood, and build a sizing box, right? Fit in the box, right? Pay attention to those rules. We have teams who bring things that, well, I have this attachment, it sits on there, and well, when you put the attachments on, it actually goes over the motor count, right? You actually have 9 or 10 motors or something. Well, I'm splitting motor power, so I'm still using the 8. No, there's an 8 motor limit. It doesn't matter, right? So pay attention to all that. Do a strategy session. We're going to host a little bit of one today. I'm sure you all do some during this week. But figure out, right, what are the points you can get? How many points are available? What are they worth? How many points are usually available in teleop in terms of a percentage of the game? Anybody want to guess?
A lot.
Yeah. Some games that can be half the points of the game are in teleop, or in autonomous, right? And then teleop can be crippled if you didn't do the right things in autonomous. So you need to think through what are the points available and are there things I have to do in autonomous to be able to get there? Right? If you don't have a good autonomous most years, you will have a real challenge in winning a match. Right? There have been years where, I remember one year we had some robots we were competing with, the average score, or the high score for the day overall was 120 points, and we had an autonomous that did 120 points. Right? Game was over at the end of autonomous. So autonomous can make all the difference in the world. Be thinking about it. A good autonomous early in league match play is killer. A lot of the teams won't spend much time on autonomous early. If you can master some of the autonomous early in the season, it makes a huge difference, and you'll get some of those early wins that will help you in your scoring as you go into rankings in the league championship. Think outside the box, right? Don't worry about what a robot could do. If you could have a mini you, right, maybe that's only 2 feet tall or something, go on the field and grab things with your hands. Yeah, I know the weight would make them impossible to move if you were actually that size, whatever, but just think, what would it be like if you could hire a monkey to go do it or whatever? How could these things move? What could they do? Then figure out how to do it with a robot or not, right? Maybe you can't do it. But don't start with, how can I build that? Start with, how could we get the points most effectively? And then figure out what you can build, right? How do you get the robot parts to do it? Can you do a drivetrain for that? Can you build software to manage it, right? And how do you keep it simple? We have a KISS principle, keep it simple, stupid, right? Don't overcomplicate things. Something that's simple and reliable and fast will win. It doesn't need to be complicated. Most of the complicated parts I see people going out and working really hard in building fail on them during competition. If it doesn't last through 4 practices, it's not going to last through the matches you're going to have in competition. Keep it simple, make it easy, don't get overly elaborate, it's not going to help. All right, how do you build a robot? Figure out a drive base. This is a tank drive, right? Left versus right, I've got 2 controls and I just go. We put Omni wheels on the back so the back end just slides and the front wheel is tracked, right? You can do this, it's very simple, it's easy to build. You can do Mecanum wheels, right, which is a vector drive that lets you go easily forward and can slide sideways, and sometimes can work well at angles in autonomous, sometimes not, depends on how you build it and the parts you use. There's the swerve drive where each wheel swerves independently. I don't recommend trying that unless you have some folks who really want to play with some advanced code. But the Wheeler kids who had one last year have posted their code on GitHub, and they've posted the resources to go build it, to go fabricate the parts out on Thingiverse, right? So you can download the CAD and you can print the parts, you can download the code, and if you want to go play with that, I hope you started in July, because you really want time. It took them 18 months to build that and get it working. You might start it at some point for next year if you really want to do Swerve, but again, a complicated drivetrain is tough. You want to get something going so you can build for your season. Build a robust frame. So this has a simple frame that goes around the outside. It's strong, it's sturdy. You can pick it up and drop it. If your robot cannot survive being dropped from 12 inches off the floor, like every single day, you need to rethink how your robot's built. Right? It needs to be able to take some abuse. You will hit walls, you will be hit by other robots, it will drop out of the back of the car, things are going to happen. Delicate robots are not going to survive. So be prepared to be brutal to them. By the way, I've done that kind of test on some of the robots and bent the axles. If your axles are going to bend from that, new axle time. Right? Don't put the weight, so your motors usually have an axle coming right out of them, right? If you secure the motor to the robot and you put a wheel on the axle and all of the stress of the weight of your robot is going through the gears of your motor, right? What happens when you do tests like that? Right, it mangles all the gears inside your motors, which means your motors live a much shorter life. Motors are some of the most, well, aside from the electronics to drive it, right, they're pretty expensive on here. Do yourself a favor, offload that weight. Even if it just means you put something on the axle so the robot weight sits on there and the wheel and the motor are both suspended on the axle. And again, you can work with mentors and figure out how to do that, but don't let the weight be on your motor. Right? Take it off. In this case, we've got motors turning gears that turn wheels that are on axles. Right? The motor can turn the axle directly, but the weight can't go on the motor. Hope that helps. I just warn about that because we see a bunch of teams losing motors in competition because they put all the weight on their motors. Think about your manipulators. How do you reach out and grab things? How do you intake particles? Again, how do you meet your goals with those? Without sensors, your robot doesn't know what's going on. In autonomous, it's critical because if the robot's just running around blind, you can't do much, right? So you may need a color sensor, you may need distance sensors. Some people want to drive straight along the side of a wall, right? A distance sensor can help you stay the right distance from the wall. A number of things you can do with sensors and all. So, yeah, if you got to go, free. And feel free to go out to YouTube, use the web, go get ideas. Talk about some of that in the software class. There's a whole bunch of great ideas out there. You're not the first one to try and solve these problems. You won't be the last, but go out there and get ideas. And if you come up with some really good stuff, at the end of the season, post them. right? First, at the beginning of the season, everybody can use it against you this year. Ideas you have this year don't count for your genius next year, right? So if you post them and people use them and they give you comments, you can use that for outreach. Right? So share your good ideas by the end of the season. Help everybody improve next year. Okay, so what are the rules in this as you go to build a robot? We've got each of these hubs has four motor ports with encoder support. Right? So if you have a motor and it has an encoder on it, you can plug in the power, you plug in the encoder, pretty simple and done. So you can see you got 4 motor ports here with the encoders right next to them. You've got servo ports, which are down here across the bottom. And then on the side, you've got the sensors, I2C ports, and the analog and digital I/O. You also have 5-volt power. So if you have LEDs you want to put on your robot and they're 5-volt LEDs, you can just plug them in there. If they're 12-volt, you're buying the cheap stuff at Kmart or whatever, right? You can literally just plug it into the 12-volt power from the battery, and you got lights. LEDs are not nice. Don't focus on them too early in the season because they can distract you. And I've seen more robots get shorts in their power system from putting LEDs on than from any other thing that they do. So be prepared to unplug them. What else? There is a IMU built into the individual hubs. IMU is an inertial management unit. Right? This will tell you your current orientation as well as your current speed and your acceleration in all 3 dimensions. So you actually have 9 different vectors, right? X, Y, and Z for each of current positioning, current heading, right? For your velocity and your acceleration. And you might not think that's really magical, but in autonomous it truly is. One of the things, if you pull the heading, it's basically a compass. 0 to 360 degrees, which way am I pointed? Right? There is nothing like it in using autonomous to try and build a robot that's driving the right direction. So we got sample code in here that uses that, and you can play with that.
How's the accuracy on that?
Dead on. We've never seen it be off by more than 1 degree. I mean, it's dead on every time. So yeah, the IMU is awesome. You got 2 of them. If you really wanted to build some complex code, you can check the other one. We haven't seen it be a problem at all. We've used it, the Wheeler kids used it all last year for driving their swerve and orienting the top and all. It's awesome every time. We didn't get a single bad reading. Right? We didn't have any one time where it suddenly jumped to some other setting and came back. It was just perfect.
And the best location for really getting deep data on that?
Doesn't matter. Oh, you want to get deeper about how it works?
Right.
I've got the sample code. Read the sample code. It's easy. So you're going to have 2 of them because you got 2 IMUs. They are designed to be daisy chained together. When you put these 2 together, you can control 8 motors. How many motors are you allowed to have in a robot? 8. You can control 12 servos. How many servos are you allowed to have? 12. Right, so you can control everything you need with 2 rev hubs. All you have to do is daisy chain them together. It also works very nice when we get up here and you start looking at this robot, all right, 2 rev hubs. The rev hubs are not next to each other. They're on opposite sides of the robot. Why do you think we did that?
Balance the weight.
Well, you can balance the weight, but
control each side separately?
right, so you've got a couple of control wires here wiring together, but all the motors on the right side go to the right hub, all the motors on the left side go to the left hub. You have a whole bunch of wires running through the middle of the robot. Right? You have 2 wires here that do power and communications between the 2 hubs, and other than that, there's no wire that has to cross the midplane of the robot. Right? Makes it simple, keeps your wires short, keeps it easy. So 2 rev hubs to drive everything, and you're off and happy. Your phone goes into the top of the first hub. That makes it the master, whichever one gets the phone plugged into it. So the phone plugs in the top, the battery plugs in the side, you daisy chain power, you daisy chain the RS-45 cable, and you're good to go. When you do 2 hubs, they each have an identifier in them. The identifiers can't be the same. It doesn't matter what they are, they just can't be the same. So you need to go in and use the app and scan through it, and again, there's some notes in here about how you can change it. I think it's on the next screen, right? But that's not that hard. So you're going to put these 2 together, you'll pull it up in the robot app on your robot controller, and you'll see both of them. So in terms of setting the ID, right, you plug your phone in the top, right, you can have the battery in or not, the phone will actually power the hub, and then I'm going to walk you through the menus over there, but you open up the settings, right, so you click up here on the top, you click on settings, right, in settings, you click on advanced, right, the 3rd button down there, you click on expansion hub, change, right, address change right there, and now you pick, it'll show you the serial number of your hub and the address. Pick a new one, save it out, done. right? It's that easy. So you pick your hub address and you move forward. Just make them unique, right? Otherwise, you're going to sit there and spin your wheels thinking about it. When you go to set this up, so I've built my robot, right? I've got my hardware put together. I'm going to build. This is how to connect things in. I'm going to say I want to find things. So I go into the menu, and then I say, gee, I'm going to go into settings, right? Or into the configure robot. Right? So I click on configure robot, and it shows me my available configurations. The first time you do a robot, you just hit new, right? And then it says, hey, I didn't find anything. If it didn't find anything, you're in trouble, right? Go plug things in again. If it finds them, you'll see, I've got an expansion hub, and you will see a serial number. Yes, this is locked to the serial number. The XML and all will have that one serial number. If you change your hubs, you've got to go in and edit the XML and change the serial number. Right? Within the primary expansion hub, which is what? How do you tell which one's primary? Right, phone's plugged into it. You will see the two hubs, logically with the numbers that they have associated with them, and then you can drill into each hub and see the motors and servos and everything that are designed to be within that hub. Right? So when you want to plug in motors, you pick a motor. So you select motors. Within each motor, you can say, well, it's not a motor, or I don't know what kind it is, or you pick these. You want to be using the right motor type. There are different settings in the code for the different motors and how their encoders work. Some of them use different encoder values and such. So make sure you do that. Try and get them right. You'll test it. You'll play with it. There's a whole lot of motor types in here. Right? And people keep coming out with new motors, so know that you'll have to make some adjustments, but it'll be pretty close. And then when you get done, you give them names. Now here I named them A, B, C, D. When you type things on the Android phone, and you all may have Androids, you may be more used to it. When I try and type things on the Android, I find that it's constantly doing autocorrect changes to whatever I type, especially if I'm typing robotics type things that don't make sense in most people's real world. So just give it some simple names, because you can edit the XML file in a text editor later. Right, so the names you put in here are just to have some default names so you know which is which. And then you can edit it later in the text editor and figure it out. Same kind of thing with servos. You click on the servo button, and then within each servo, it's either a continuous rotation servo or it's a regular servo, right, which has fixed positions. The Rev servos actually can switch back and forth between them. You just have to make sure you tell it which way it's being used, because they work very differently. And then again, give them dummy names, and away you go. And then you can go look at other devices. So you can say, gee, I get digital devices, I get LEDs. You can play with sensors, right? Analog input, touch sensors, lots of stuff. So we've got all that set up. We've got them all figured out. We've got the addresses for the hubs. All my devices are ready. We've got them named. Oh, sorry, the sensors. So then I got my sensors, right? So this is a Adafruit sensor, and a whole bunch of different kinds of sensors I can add in there as well. The IM user built in, you don't have to do anything for those. And for those of you who've done I2C programming or the USB programming, essentially USB protocol, each of these is treated as a separate bus, so the sensors won't talk to each other and confuse each other. Some of the old versions we used to do shared the ports and made it much more complicated. The Rev has made a lot of that very simple. Right? Put your certain sensors on separate ports, and you're good to go. So pick the sensors and go have fun. Words about compatibility. So all the servo ports are 5 volts. Every servo we found, even the cheapest things we can buy off Amazon out of China that ship direct to you, really cheap by the way, will work at 5 volts, and they're happy. You can plug them in and go use them, and that's great. When you're doing the I2C ports, right, the sensors and all that, Rev does all their stuff at 3.3 volts. So all the Rev sensors work automatically, and it's great. If you have other sensors, they may well be expecting a 5 volt input, in which case Rev makes a very nice little part you can plug in that will change the voltage from 3 volts up to 5 for your parts. If you fail to use that, the bad news is your other sensor may work part of the time, right? It will get flaky on you, it will drop out, it will give you bad values, and you will not know why. and it will drive you more than a little crazy. So do yourself a favor, check the power early, and if you need to convert it, do the power conversion. There is no support for legacy NXT stuff in here, which is just as well, because our NXT parts legal for FTC? No, they are not, right? So they got rid of those last year, year before. So that's all gone. Too bad. Those little FLL or NXT motors, those were strong. They had really good encoders in them. I miss those. But, things change. When you're using the hub, read the expansion guide. It talks about this. Right? Just like I said, reading the manuals for the game, read the guide on this expansion hub. It's not long. It's only, I don't know, 12 pages or something. But you want to be aware of power. You want to be aware of all the ways that this thing works. Again, this is the core to your robot. If this isn't working right, you don't have a working robot. So what's the configuration look like? If you open up the XML file, and again, you're going to copy this onto the computer, and you should open it in an editor and edit it. You're going to see that it says, I'm a First Inspire robot for FTC. I have an expansion hub and a serial number. Again, locked to your serial number. Luckily, it no longer puts in the serial number for the second hub, but it does know where the second hub exists, right? An expansion hub, right, it calls itself 5. So it means its ID is 5, right? If you replace that secondary hub and the ID is no longer 5, this XML doesn't work. So what happens when you start the robot and this doesn't match?
It crashes.
Nope. It just ignores everything it can't find. It gives you no errors of any kind. But if you open up the configuration on the robot, it'll say, oh yeah, by the way, there's no configuration here. Right? So just be aware that errors in this are not easy to figure out. So get it set up early, but do go back in and open up your robot and make sure that what you're seeing is what you're expecting. There's a tool in the software class. We talked about how to do ADB push and pull. Use the Android debugger. You can grab the XML file. So you build the default one on the robot. You can pull that one out. You can edit it, and you can push it back onto the robot. Right? So you don't have to go and type all the names and clean everything up and manage it on the phone. That also means that if something happens to your robot phone and you have to get a new one, what are the two things you need on a phone to be able to control a robot? Right? You need the robot control code and you need the XML file to match it up to the hardware. Right? If you don't have backups of the XML and something happens to your phone, you get to go start over. Odds of you getting it right quickly, not good. Right? Make backups of this with all your code. And then, of course, you're going to back up your code at least weekly. Right? Put it in GitHub, sync it to friends, do whatever, make extra copies, but make lots of copies of the software. But it's pretty simple. Well, within each module, I've got a motor type, a name of it, and the motor port it's plugged into. It doesn't have to say motor port because it knows from this that it's a motor. Right? I'm a servo in servo port 5, and I named it grab. Right? I've got my internal IMU, right? And I'm going to have that down here as well. Right? So I've got IMU here, I've got IMU 1 here. We only ever use one. We've never had them fail. And again, it's the most awesome part that we've had on a robot in a long time. What's really funny is that the little part they put in there, you can buy them online for like $8. They're super cheap, and it's better than any of the gyroscopes or anything we've ever had before. It's just awesome. All right, so what else do I recommend? So now we're talking. So any questions about the fundamentals of wiring this up? All right. So I've got an example here. There's lots of ways you can wire up your driver station. There's a really simple piece of wire hanging out of this phone. Right? It has 2 connectors on it. 2 USB-A connectors, each of which you can plug a controller into. How many controllers are you allowed to use? Right. So what does this let you do? It lets you have one cable that you use that connects both of your controllers directly to your driver station, and you're done. You can do a little twist in them. Why would I twist it like that? Right, so it doesn't just pull itself apart when I put stress on it. Of course, it'd be really nice if I took all of this and zip tied it to something and took all the stress off my phone. One of the things we've seen is these get broken a lot. Building a platform to hold this together so that it doesn't get all that stress and get broken is a nice idea, but this is still going to get pushed and pulled constantly while you're plugging in batteries and doing other things. These cables are going to break. You can buy one of these or something just like it on Amazon for $6. Don't order one, right? Order 3 or 4 each time you do it. They'll come and you'll have them. I ordered a set of 2 a couple weeks ago. One of them came in dead. But for $6, I'll just toss it and start again, right? These will die throughout the season. Just have a few spares lying around. And again, you can download the PowerPoints of this from the QR code that's on the wall and will be up at the end of the class. So this is just a simple, easy way to do this. There's no separate external hub. There's no separate OTG to hub. It's fewer connections and fewer simple, again, this is keep it simple, stupid, right? Really simple stuff, make it easy, make it redundant, keep it cheap. Other useful parts. This is built out of some of the Rev extrusions and all. Rev makes these cool new motors. I don't know if you've seen them, but the axle comes out the side. So instead of your robot, you're having a motor poking into the middle of your robot, the motor pokes up and the power comes out sideways. For building robots with a lot of space in the middle, that can be really useful. The Build-A-Bots have an idea. They've got one. You can build their Build-A-Bot. How many of you are rookie teams, by the way? So I don't know if you've seen it yet, but if you go to the Go Builda folks, right? Go Builda is the name of one of the companies that makes robot parts. Go Builda has you can get our base kit that has 4 motors and a set of Mecanum wheels and a set of frame parts. It's a $500 kit. If you're an FTC rookie team, you send them a note, they'll sell it to you for $100, right? Even if you decide you don't like some of their stuff, that is one of the best deals in the world. You got 4 great motors. If you just use the motors, it's worth $100. If you use the Mecanum wheels, they're worth at least $100. Well, they list for like $170 by themselves, right? They're really good Mecanum wheels. They have ball bearings in each of the rollers. It doesn't get much better. You get all kinds of parts. If you're a rookie team, if you don't want it, let me know. I'd like to use your team number and buy one. How's that? It's a great deal. So the other thing that I really like about some of the Rev stuff is the wheels and the way they do their wheels and axles for the motors is it's a hexagonal axle, right? So instead of all of the tension being held on the fact that there's one flat side on your axle that forces all the turns, you have 6 flat sides on the axle that force things to turn, right? So one side is less than 6. 6 does a better job of transferring power cleanly without breaking things. The Tektronix robots were particularly bad at putting all the tension on just one set screw. The others do much better. If you're using Servo City parts or Build-A-Bot parts or whatever, right, that all is better. But I really like the way Rev does their particular hubs. Mecanum wheels, so I mentioned the Go Builda wheels. The Mecanum wheels are the same kind of thing. So you got a simple wheel with metal in the middle. You've got rollers. So every Mecanum wheel has multiple rollers. There are ball bearings inside of each roller. Right? We've used wheels without ball bearings in them. They have extra friction. Since this is a vector drive that is entirely based on force and friction, the last thing you want is friction in your wheels slowing you down. So I strongly recommend if you're going to use Mecanum, get something with a ball bearing in the rollers like the Go Buildas or these. The other thing I really like about these is this is actually a little clip on the end of the pin, so there's no bolt head poking out. We've had problems with the 2-inch cubes that have been in several of the games where the bolt heads on some of the Mecanums catch in that and lift themselves up onto cubes. Really annoying when your automated robot that's supposed to plow right through blocks grabs one and goes up over it and goes marching off to the side in some random direction and autonomous. So think about how those work and what they might do. If you're going to climb or you need to do some kind of vertical move or fixed move that's not a circular motion, right? All your servos, normal servos, run in a circle. We have linear actuators, linear servos, that will push things in and out for you. Some of them, like this particular beast, will lift 60 pounds, 67 pounds. You could put a robot on that, grab something, and just lift the robot on a single servo. Now, how many servos can you have? How many motors can you have? 8. How many motors do you like to use in your drivetrain? 4. Right? You got about 4 powered wheels, which means you got 4 motors to do everything you want to do on your robot. If you can do a motor with one of the 12 servo ports instead of one of your 4 remaining wheel motors, right, it gives you more options. It's also a whole lot lighter than the motors and all the rest of the accoutrement. This one's got a motor going through a gearbox, right, pulling with a string. I mean, it works, but yeah, takes engineering work. All right, so we've got about 15 minutes left here because I'm going to push this till close to 11, probably with Q&A and a demonstration. If you all need to leave, just feel free. But Linton Servo City has these. You can get small ones, you can get them different lengths. Again, I recommend if you need to do some straight things, think about some of the linear servos. When you're doing wiring, think about covering it up. So I got some of this little tubing on this robot here, where we have the wires that transition across the middle of the robot. They're sitting in this conduit, right? Which means that anything that slams into it doesn't accidentally scrape through the wire. The last thing you want is your wires getting cut and sliced, and now you're shorting things out and you didn't see it happen. It protects your robot. If you're going to have lifts and such that have motors and servos and sensors on them, I strongly recommend cable chain. Right? You can get a chunk of cable chain like that, 10 feet of it on Amazon for 15 bucks. Right? It's only inch and a half wide, but it will gather together a whole bunch of your cables and keep them safe. And it will move up and down nicely with them. It will expand and contract. Right? It will just bend back and forth, and it will keep your cables where they want to be instead of getting in the middle of your parts and getting eaten up by your arms and whatever else is moving. Right? Protect your cables, or your robot will suffer. You don't want to build the same part 5 times during the season. Right? Replacing servo cables and sensor cables and all that get crimped is not a lot of fun. It's even less fun if things short out. And speaking of shorting out, grounding strap. This seems pretty silly, but there is a good bit of static electricity on the fields with First. And we will sometimes spray the fields like at the start of a day or at a lunch break, but they're not going to spray fields every match. Right? There will be static on the field. It will build up between matches. You've got lots of friction of rubber and other things working on the mats. You will find yourself getting zapped sometimes from robots. Right? It will happen. We had one robot at a super regional that the team was called Black Widows, and we thought it was appropriately named. The robot had a grounding problem. Any robot that had metal contact with the frame of that robot got zapped and died and didn't finish the match. Right? So they just went around touching robots and killing them. A grounding strap on your robot will make sure that the frame gets tied to the ground so it doesn't do something bad to your robot. So, yes?
So, and it attaches from a battery to where?
So this attaches to one of the power plugs on your hub directly to the frame. So just attach it like onto the metal frame on this. Usually you have enough contact between the metal. If you need to, you can daisy chain, connect wire to other pieces of metal. But in general, one around the base frame should be enough to deaden static electricity. Right? And again, you don't want to deal with that in competition. It's a great way to help prevent it, and the part costs $4. Right? While you're buying other things from Rev, just get one. It'll make you happier. It's well worth the $4 investment.
So, if you were intentionally trying to make your robot very static toxic, but control that, like the carpet.
So if you were trying to find ways to gather static electricity, there are things you could do. I mean, among other things, if your robot's there and it's going to hold it, you can just shuffle your feet around and go touch the robot, right, and give it a whole bunch of static. You will zap the robot instead of the robot zapping you. But if that's sitting on the field, then it's got static electricity. Now, if anyone was to find you intentionally doing that to your robot as a way of competing, that's really against gracious professionalism, right? Not only might you be thrown out of the event, but you would certainly be disqualified from receiving any award. Right? And just to be clear, violations of gracious professionalism are the easiest way to make sure you are ineligible for any award at the competition. It can even prevent you from advancing from a competition if it's egregious enough. So just be gracious, right? That's where First starts, is with the gracious professionalism. If you don't have that sense for this, you're really in the wrong group. Because they're all about it, and for good reason, right? We're all trying to learn to be good engineers and work together. We're not hostile countries trying to hurt each other. In the end, one of the sayings they used to use from FLL, right? What we learn is more important than what we win. And we really should be taking that to heart in what we're doing here, because in the end, I mean, a trophy is going to sit in a school somewhere that you're going to leave, right? You're not going to take it with you. The experiences you have with your friends, the things you learn from the robots, right, all the work that you do here is much more valuable than winning something in one of these events. When you go to build intakes, when you're thinking about what to build, yes, you can use surgical tubing and connect it with things. You can also buy pre-made parts like this. You can also buy TPU, flexible plastic, and instead of 3D printing hard parts like we've got the signs and all on here, you can 3D print things like this. So one of the teams at Worlds had an intake mechanism like that. They specifically put little T's on the ends because it would do a better job of grabbing the balls, right? You can make them look in any shape. This one happens to be a 3-vectored thing that one of the kids from Wheeler designed to build, so you could scoop in balls and it had a nice big angle in the middle. So again, feel free to think about how you want to build things. Prototyping rapidly with simple parts like surgical tubing or duct tape and cardboard, right? Any of that kind of stuff is awesome. We got to 11, right? Yeah, okay. So prototype fast is great, but think about what you can 3D print. The other thing I like about 3D printing is that when you get done with 3D printing things, you can print exact copies. So if you break one, the replacement works exactly the same, so you don't have to change your code. All right. So I'm going to go down to demonstrating robot pretty much now. We do have some Slack pages. So if you're a coach or a mentor, we have a Slack page for coaches and mentors to talk about managing teams and finding things and all, finding resources. Students are welcome to use the general resources page. So if you want to join either of those, you get trouble finding it, just send me a note. I'm glad to talk to you about it. We didn't get a lot of activity from the student side last year, but we've got a lot of interest right now from the coaches. So again, if you're interested in doing stuff with Slack, just send me an email and I'll help you do that. And again, my email is still here. There's the QR code for the downloads. So this has the PowerPoints for this class as well as the software class. It has the PowerPoint sample for how to build your team identifiers from here. It will have this video and the code video, and it has the sample code and XML for building the robot. So that's here. It's posted outside the room. That'll help you with that. So I've got the robot up here that we can drive if you all want to try driving a robot. Given where we are on time, I'm probably just going to officially end, and you all can, or any questions?